For our first lesson in Chapter 10, we're going to be discussing sequences and series. So in general, we're going to try and identify patterns, and use those patterns to help us identify terms within a specific sequence. Let's get started. For our first definition, a sequence is a pattern of numbers in a specific order following a specific rule. And that's going to be our goal for this chapter. How can we identify a rule and use it to identify terms for that specific sequence? For each one of these examples, we're going to try and identify the pattern by finding the difference between consecutive terms, and use that to try and figure out if there's a trend. For our first example, our first sequence, if we go from 5 to 12, that is a difference of 7. From 12 to 19 is a difference of 7. And from 19 to 26, it's again another difference of 7. And I guess we should know these are all positive. Since our difference between consecutive terms is the same every time, that's our pattern. We're adding 7. Looking at our second sequence, again we're going to try and identify the difference for consecutive terms. As we go from 6 to 8, we add 2. From 8 to 10, we add 2. And then from 10 to 12, again we add 2. So that is our our pattern. We're adding 2. Moving on to our third one. For our third sequence, as we go from 4 to 8, we add 4. As we go from 8 to 16, we add 8. And as we go from 16 to 32, we add 16. So now we notice that our difference is not the same between consecutive terms, it's changing. But we can use that to help us identify the pattern. So first we added 4, then we added 8, then we added 16. So we're adding, or almost doubling what we're adding here, right? And if we look at our terms, from 4 to 8, we multiply by 2, from 8 to 16, we multiply by 2, and from 16 to 32, again, we multiply by 2. So our pattern here is that we are doubling, or multiplying everything by 2. Looking at our last sequence, again we're going to identify our common differences. So from 2 to 4 we're adding 2, then we're adding 4, then we're adding 6, and then we're adding 8, and lastly from 22 to 32 we are adding 10. So again our differences are not the same, but we can notice a pattern here. We added 2, then 4, then 6, then 8, then 10, so we are adding consecutive even numbers. So again, just to recap, when we're identifying the pattern, you want to find the difference between consecutive terms. If it's the same as it was for our first two examples, that is your pattern. If it's different, as it was for our last two examples, then you want to look at those differences between consecutive terms and use that to identify what the pattern is. Sometimes you're given the formula for a sequence to help generate the terms. So our formula here reads a sub n is equal to 3 times n minus 2. A sub n represents a term in the sequence. N represents the position in the sequence. So if I wanted to find the first term, then I would plug in a sub 1 is equal to 3 times 1 minus 2. So again, a sub 1 denotes I'm looking for the first term. Since it's first in our sequence, I plug in a 1 for n. And when I simplify, I get that my first term is equal to 1. If I wanted to find the 10th term, then I would have a sub 10 is equal to 3 times 10 minus 2. Again, note that we have a sub 10, which tells us we're finding the 10th term, and I'm plugging in 10 because it's the 10th term in the sequence. When I simplify that, I get 28. Now we can use this formula to find any term in the sequence that we want. Here's another formula that is a little different. We have the same notation though. A sub n is equal to 1 plus negative 2 to the n. Again, a sub n represents the term we're looking for, and n is the position in the sequence that term falls in. If we plug in some numbers here, let's say I wanted to find the third term. So then a sub 3 is equal to 1 plus negative 2 to the third. It's important to note that when you put this into your calculator, you should use parentheses because your exponent, if it's even or odd, will affect if you have a positive or negative number. In this case, we get 1 minus 8, which means our third term is equal to a negative 7. If I plugged in 4 to find the fourth term, then I have 1 plus negative 2 to the fourth, which means I have 1 plus 16, giving me 17. So again, it matters what kind of exponent we have with the negative values. Make sure you keep them in parentheses. Our last type of sequence we're going to look at for this section is called a recursive sequence, and this is generally the most challenging to kind of comprehend. We have a formula here, and our formula says a sub k plus 1 is equal to a sub k plus 3. What this means is whatever term we're looking for, the k plus 1 term, is directly related to the term that comes before it. So when we're doing these sequences, we have to have the first term defined, otherwise there's no way to figure out what the next term would be. This also means that I can't find a term without knowing what came before it. So the only term I can find right now would be the second term. And I'm going to do that by plugging in 1 for k. So if I do that, I get a sub 1 plus 1 is equal to a sub 1 plus 3, which means my second term is equal to my first term plus 3. Now I can plug in my first term. And I get that the second term is equal to 18. If I want to find the third term, that would be a sub 2 plus 1. Then my third term is equal to the second term plus 3. So again, we just have the pattern here. Whatever term we want is based off the term before it plus 3. Same as it was for our second term. It's based off of the first term plus 3. So now I would plug in what my second term was, and I get a sub 3 is equal to 21. So now that I know my third term, I could go back and find my fourth term. And so the pattern is a sub 4 would be a sub 3 plus 3. A sub 5, or a fifth term, would be a sub 4 plus 3. And so on until I got down to, let's say, one of the 20th term. That would be the 19th term plus 3. So for recursive sequences, whatever term you're looking for is always based off of the term that came before it. For this example, I would like to see you guys try and find the first 5 terms for this sequence. Now since I've already given you the first term, that means you only have to find the next 4. But use the idea of the recursive sequence to help you find that. Go ahead and type in your response. Sometimes we're not too concerned with what the actual terms are. Sometimes we just want to know what they all add up to be. So anytime we see this notation here, that sigma means to add up all of our terms. And we're going to add up terms starting from the first term until whatever n is. So n will tell us basically how many terms we are adding together. For our first example here, we want to find the sum of the terms for the sequence 3 times I, where I starts at 1 and goes to 5. So what that means is I'm going to start by plugging in a 1 for I, and I'm going to stop when I've gotten my first 5 terms. So when I expand this out, I get 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. So I would multiply and then combine those all together, and because I have my sigma notation, that's telling me that I want the sum. So my actual answer here is going to be what they add to, which in this case is 45. Here we have another example of sigma notation. So again, this is asking us to plug values in from 1 to 4 into the equation 2 to the k. I'd like for you guys to go ahead and evaluate the sum of those terms. So expand out the sequence, getting the first 4 terms, and then add them together and record your response. For our last example, we're going to do one more sigma notation. We're going to expand this out and then find the sum. So again, we're going to plug in values from 1 to 3 into I, which means that for my terms, I have 3 over 10 to the first, plus 3 over 10 to the second, plus 3 over 10 to the third. And then again, we want to evaluate the sum. So when we add these all together, we get 0.333. Alright, that concludes our lesson for today. Tomorrow in class, we're going to be applying the idea of identifying patterns, finding terms in a sequence, and then finding the sum of a sequence. See you tomorrow.